Hello and welcome to Vision Mathematics. My name is Thomas Vanda and I'm going to take you through the lesson on this video. Lesson number 1. Compound angle formulae. Let us begin by explaining what a compound angle is. A compound angle is an angle that is expressed as the sum or difference of two angles. Let's have an illustration. Let alpha and beta be two angles. Then alpha plus beta is the sum of two angles. It is a compound angle. Alpha minus beta is the difference between two angles. It is a compound angle. Before we can prove our first compound angle formula, we need to rewrite the coordinates of a general point in the Cartesian plane in a convenient way. Now let P be a point lying on a circle with center O and radius R. And let the angle between PO and the positive x direction be theta. Now, in grade 11, we defined the trigonometric ratios in terms of x, y, and r. X of r is equal to cos theta. On multiplying both sides of this equation by r, we obtain x equal to r cos theta. Y over r is equal to sin theta. And again multiplying by r, we obtain y equal to r sin theta. Therefore, the coordinates of P can now be written as r cos theta, r sin theta, since x is r cos theta and y is r sin theta, and the coordinates of P are x, y. Now, if r is equal to 1, the coordinates now become simply cos theta, sin theta, because that will be 1 multiplied by cos theta, which is cos theta, and 1 multiplied by sin theta, which is sin theta. Now we are ready to prove our first compound angle formula. Proof of the compound angle formula for cos alpha minus beta. Let P and Q be points on the circumference of a circle with center O and a radius of 1 unit. Let the angle POX be alpha. That's POX. This angle here is alpha. And let the angle QOX be beta. That's QOX. This angle here is beta. Then, as we indicated on the previous slide, the coordinates of P can be written as cos alpha sin alpha, since the circle here has radius 1 unit, r is 1. Similarly, the coordinates of Q can be written as the coordinates of Q can be written as cos beta sin beta. And the angle POQ is alpha minus beta. We have said POX is alpha and this is beta. So this one is the alpha minus beta here. So this is alpha minus beta. It's the angle of the triangle POQ. It's alpha minus beta. Now, in triangle POQ, we can find the distance PQ using the cosine rule. That's pq squared equal to 1 squared plus 1 squared minus 2 times 1 times 1 cos alpha minus beta. And simplifying that, that's 1 plus 1 giving us 2. And minus 2 times 1 times 1 is minus 2 cos alpha minus beta. Let's call that one equation number 1. Now we can also find the distance PQ using the distance formula. So by the distance formula, PQ squared equal to the difference between the x coordinates. That's cos alpha minus cos beta all squared, plus the difference between the y coordinates squared, which is sine alpha minus sine beta all squared. And squaring this, it gives us cos squared alpha minus 2 cos alpha cos beta plus cos squared beta. And squaring this, we obtain sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. Then simplifying, we obtain pq squared equal to 2. This is cos squared alpha plus sine squared alpha is 1. Then cos squared beta plus sine squared beta, that's the other one. Then 1 plus 1 gives us 2. And then minus 2 cos alpha cos beta. And minus 2 sine alpha sine beta. This gives us equation number 2. Now looking at the two equations, the left hand sides are equal. Therefore the right hand sides are also equal. So we can equate the right hand sides of the two equations. Thus we obtain 2 minus 2 cos alpha minus beta equal to 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. And subtracting 2 from both sides will eliminate these 2's. So we remain with minus 2 cos alpha minus beta equal to minus 2 cos alpha cos beta minus 2 sine alpha sine beta. And on dividing everything by negative 2, we obtain cos alpha minus beta equal to cos alpha cos beta plus sine alpha sine beta as our first compound angle formula. Deriving the compound angle formula for cos alpha plus beta. We have proved that cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. We are going to use this to derive the compound angle formula for cos alpha plus beta. We rewrite cos alpha plus beta as cos alpha minus beta. I hope you can see that these two negatives make a positive, so this and this are the same thing. Then this looks like this, where beta has been replaced with minus beta. So expanding that means simply replacing beta with minus beta here. So we have cos alpha cos minus beta, that's replacing this beta with minus beta, plus sine alpha sine minus beta, replacing beta with minus beta here. Now in order to make progress, we have to remember what we learned in grade 11. Let's have that. We learned that cos minus beta has the same value as cos beta, and sine minus beta has the same value as minus sine beta. So we use these to substitute here to simplify the expression. That's where there was cos minus beta, we put cos beta, and where we had sine minus beta, we put minus sine beta. and multiplying out the bracket here, plus sine alpha multiplied by minus sine alpha gives us minus sine alpha sine beta. So that is the compound angle formula for cos alpha plus beta. Deriving the compound angle formula for sine alpha plus beta, we will use what we have already proved. That is cos alpha minus beta equal to cos alpha cos beta plus sine alpha sine beta. We will also need the relationship between the sine and cosine of coangles. Remember, coangles are angles which add up to 90 degrees. So if one of the angles is x, the other one is 90 minus x. The relationship is that the sine of one is equal to the cosine of the other one. Now, we start by rewriting sine alpha plus beta as cos 90 degrees minus alpha plus beta using coangles. Then removing the brackets here, we obtain 90 degrees minus alpha minus beta. Next thing, we regroup. We group 90 degrees with alpha, so that we consider this as one angle. Then this looks like that, with alpha now replaced by 90 minus alpha. So in expanding that using this formula which we have already proved, it simply means that we replace alpha with 90 minus alpha here. So that's in this formula, replacing alpha with 90 minus alpha, we have cos 90 degrees minus alpha cos beta, and replacing sine alpha with 90 degrees minus alpha, we obtain sine 90 degrees minus alpha sine beta. Now at this point, that is where we need these relationships which we have indicated above. That cos 90 degrees minus x is equal to sine x. So here where there is cos 90 degrees minus alpha, we replace with sine alpha. So that's sine alpha cos beta. And here where we have sine 90 degrees minus alpha, we replace that with cos alpha. And that gives us the compound angle formula for sine alpha plus beta. Deriving the compound angle formula for sine alpha minus beta, we will use the compound angle formula for sine alpha plus beta which we have just proved. Rewrite sine alpha minus beta as sine alpha plus minus beta. I hope you can see that this simplifies to that. So it's the same thing, we haven't changed anything. Now comparing sine alpha plus beta with this expression here, you see that it is the same expression with beta replaced by minus beta. So in expanding this using this compound angle formula, we simply replace beta with minus beta. Replace beta with minus beta everywhere in the original formula. So this will expand to sine alpha cos minus beta here, plus cos alpha sine, replace that with minus beta. Then as we did in the previous example, we will now use the relationships that we learned in grade 11, that cos minus beta is the same value as cos beta, and sine minus beta is the same value as minus sine beta. So substituting for these, we have sine alpha cos beta and cos alpha multiplied by minus sine beta, and removing the bracket here, we obtain our compound angle formula for sine alpha minus beta, which is equal to sine alpha cos beta minus cos alpha sine beta. Let's summarize all the 4 compound angle formula we have proved and derived. There we are. We have 2 pairs. One pair is for sine alpha plus beta and sine alpha minus beta, the ones for sine. Let's look at the pattern they have. It's sine, cos, sine. Sine, cos, sine. Both of them have the same pattern. And let's look at the signs. If you have plus on the left, you also have plus on the right. If you have minus on the left, you also have minus on the right. These are the compound angle formula for sine. That's our second pair, the compound angle formula for cosine. Let's look at what pattern they make. This is cos, then sine. Cos, sine. They have the same pattern. The difference with the above, if you have plus on the left, then you have minus on the right. If you have minus on the left, then you have plus on the right. So these are the 4 compound angle formula. They are also given in the information sheet in the examination. Let us now have a few examples. Prove that cos 90 degrees plus theta equal to minus sine theta. We observe here that 90 degrees plus theta is a compound angle. So that suggests that we can use the compound angle formula. So cos alpha plus beta equal to cos alpha cos beta minus sine alpha sine beta. Please refer to your information sheet so that you don't misquote the formula. Then substituting cos 90 degrees plus theta is equal to cos 90 degrees cos theta minus sine 90 degrees sine theta. Now 90 degrees is a special angle, so we substitute for the values of cos 90 degrees. Cos 90 degrees is 0 and sine 90 degrees is 1. So that's 0 times cos theta minus 1 times sine theta. Now this disappears. 0 times cos theta is 0. So we have our final answer, cos 90 degrees plus theta equal to minus sine theta as required. Example number 2. Given that sine alpha equal to 4 over 5, where alpha is acute, and cos beta equal to minus 12 over 13, beta between 0 and 180 degrees, evaluate cos beta minus alpha without the use of a calculator. Now, cos beta minus alpha, we have here beta minus alpha is a compound angle. It suggests that we have to use the compound angle formula. Now, in order for us to use the compound angle formula, we will need the sines and cosines of both angles. Here we are given sine alpha, we need to find cos alpha. And here we are given cos beta, we need to also find sine beta. Now, since alpha is acute, we have no problem there. We can use the identity cos squared alpha plus sine squared alpha equal to 1. Then making cos squared alpha the subject, we have cos squared alpha equal to 1 minus sine squared alpha, and making the substitution, we have 1 minus sine alpha is 4 over 5. That's minus 4 over 5 all squared. And simplifying, if you square this, it gives you 16 over 25. and writing 1 as 25 over 25 so that you have a common denominator. Then you have 25 minus 16 giving you 9 over 25. And then taking square root and remembering that alpha is acute, what we are given there. So if alpha is acute, it's in the first quadrant, which means cos alpha is positive. So cos alpha equal to, we take the square root of 9 over 25, which is 3 over 5. Again, using this identity to find sine beta, we have sine squared beta equal to 1 minus 12 over 13 squared, which gives us, on squaring, this one gives you 144 over 169, and writing 1 as 169 over 169 and subtracting, you get 25 over 169. Now going back here, we are told that beta lies between 0 and 180 degrees. This covers the first quadrant and the second quadrant, but we are guided by this sign here to conclude in which quadrant beta is. Since cos beta is negative, it is negative in the second quadrant. We use the two pieces of information, the fact that cos beta is negative and beta lies between 0 and 180. And I said this covers two quadrants. The first quadrant is out because in the first quadrant cos beta would be positive. So it means that cos beta is in the second quadrant. Then when we find sine beta now by taking the square roots, we know that beta is in the second quadrant, and in the second quadrant sine is positive. So we take the positive root. Sine beta equal to 5 over 13. Now for reference sake, let's write down what we have now calculated. We were given sine alpha equal to 4 over 5. We calculated cos alpha and got 3 over 5. We calculated sine beta, we got 5 over 13. We were given in the question cos beta is minus 12 over 13. Now we have the sines of both angles and the cosines of both angles. We are now ready to use the compound angle formula to find cos beta minus alpha. So writing down the formula, cos beta minus alpha is equal to cos beta cos alpha plus sine beta sine alpha. Then making the substitutions, as cos beta, where is our cos beta? Here it is, minus 12 over 13. So put minus 12 over 13 here. Then cos alpha, that's cos alpha, 3 over 5, plus sine beta, that's sine beta, 5 over 13, and sine alpha, that's sine alpha there, 4 over 5, and then multiplying. Minus 12 times 3 is minus 36, 13 times 5 is 65, 5 times 4, 20, 13 times 5, 65, and adding those is simply 20 minus 36, which is minus 16 over 65 is our final answer. Example number 3. Given that tan theta is equal to 3/4 with theta greater than 90 degrees and tan phi equal to 5 over 12, phi lying between 0 and 90 degrees, evaluate without using a calculator. Number 1, sine theta plus phi. 2, tan theta plus phi. Now these are compound angles, so it suggests that we have to use compound angle formula. Now to use compound angle formula, we will need the sines and cosines of both angles. Here we are only given tangent. So in order for us to be able to find sine and cosine, we need r, because sine is equal to y over r and cosine is x over r. So we need to find r. in the first place we must sketch a diagram showing the position of theta and the coordinates. Now we have two pieces of information here. Tan theta is positive and theta is greater than 90 degrees. Now, tan theta is positive in two quadrants, the first and the third. But this rules out the first because we are told that theta must be greater than 90. So we conclude that theta is in the third quadrant. So let's have the sketch of the diagram. That's our angle theta falling in the third quadrant. In the third quadrant, both x and y are negative. Tan theta is y over x, so this is the x coordinate, that's the y coordinate. But the fact that this is positive does not mean that the x coordinate and the y coordinates are positive. They are both negative, and we know that a negative divided by a negative gives us a positive. So here the answer has been simplified, but the coordinates are actually these ones. The x coordinate being -4 and the y coordinate being -3. And -3 over -4 will give us a positive 3 over 4. That's the position of theta. Now we need to calculate r. Now using Pythagoras theorem, r squared equal to x squared plus y squared, and x, we have said the x coordinate is -4, y is -3. So that's -4 squared plus -3 squared, which gives us 25. And taking the square root gives us r equal to 5. Remember, r is a length. A length is always positive. So we can now write down the cosine and sine of theta. So sine theta is y over r, and y is -3, r is 5. So that's -3 over 5, which can be written as -3 over 5. Cosine theta is x over r, which is equal to x is -4. So that's -4 over r is 5. And you can write that as -4 over 5. Coming now to the angle phi, we were given tan phi equal to 5 over 12, phi lying between 0 degrees and 90 degrees. Now by definition, tan phi is y over x. Since phi lies between 0 and 90, it is in the first quadrant, and we can sketch the diagram. That's our angle phi. That's x coordinate of that point and y coordinate. Now we can find r using Pythagoras theorem. R squared equal to x squared plus y squared. That's 12 squared plus 5 squared equal to 169. Taking the square root and remembering r as a length is always positive, we obtain r equal to 13. Now we can write down the trig ratios. By definition, sine phi is y over r, y is 5, r is 13, so that's 5 over 13. And cosine phi, by definition, x over r, x coordinate is 12, r is 13, cos phi is 12 over 13. Now we are ready to calculate sine theta plus phi. Writing down the compound angle formula, sine theta plus phi equal to sine theta cos phi plus cos theta sine phi. Now we have the values of sine phi and cos phi here. We calculated the values of sine theta and cos theta in the previous slide. Let's have them here. That's sine theta equal to -3 over 5, cos theta -4 over 5. Now we can make the substitutions. That's sine theta minus 3 over 5. Cos phi 12 over 13. Cos theta minus 4 over 5. Sine phi 5 over 13. Let's multiply. Minus 3 times 12 minus 36 over 5 times 13, which is 65. Minus 4 times 5 is minus 20 over 5 times 13, 65. These have a common denominator, so the numerator is simply minus 36 minus 20, which gives us minus 56 over 65. That's our final answer. Let's begin by writing down what we have calculated so far, because we might need that. Now, the last question required us to calculate tan theta plus phi. We remember the identity which says tan theta plus phi is equal to sine theta plus phi over cos theta plus phi. And we have found sine theta plus phi, so we need now calculate cos theta plus phi. Writing down the compound angle formula for cos theta plus phi, that's cos theta cos phi minus sine theta sine phi. Making the substitutions. Cos theta is minus 4 over 5. Cos phi 12 over 13 minus sine theta is minus 3 over 5. Sine phi is 5 over 13. And simplifying, minus 4 times 12 is minus 48. 5 times 13, 65. Minus 3 times 5 will give us minus 15. Multiplying by that negative will give us now a positive 15. That's negative times negative will give us a positive. Then 5 times 13 is 65. And then adding, these have the same denominator, so we only have to add the numerators. Minus 48 plus 15 is minus 33 over 65 as the value of cos theta plus phi. Now we are ready to calculate sine theta plus phi. Tan theta. So tan theta plus phi equal to sine theta plus phi over cos theta plus phi. Since sine theta plus phi is a fraction and cos theta plus phi is also a fraction, it will be easier if we are not using a calculator to write it as sine theta plus phi divided by cos theta plus phi. Then we will be dividing fractions. So sine theta plus phi is minus 56 over 65 divided by cos theta plus phi, which is minus 33 over 65. And if you remember well how to divide by a fraction, invert the divisor and multiply. So putting minus 33 over 65 upside down and multiplying, we have minus 5 over 65 multiplied by minus 65 over 33. The 65s will cancel, and the final answer, negative number times a negative number, gives us a positive. So that's 56 over 33. Time now for some practice. Prove that sine 90 degrees plus x equal to cos x. Given that sine alpha equal to 3 over 5, where alpha is an acute angle, show that sine alpha plus 60 degrees is equal to 1 over 10 into 3 plus 4 root 3. If 13 cos alpha equal to 5, alpha lying between 0 and 270 degrees, and 15 tan beta minus 8 equal to 0, where sine beta is negative, evaluate sine alpha plus beta, cos alpha plus beta. Here are the suggested solutions. Number 1, sine 90 degrees plus x. 90 degrees plus x is a compound angle, so we expand that using compound angle formula. It expands to sine 90 degrees cos x plus cos 90 degrees sine x. And substituting for the values of sine 90 degrees and cos 90 degrees, sine 90 degrees is 1, cos 90 degrees is 0, and simplifying, 0 times sine x is 0, so we remain with 1 multiplied by cos x, which is cos x. Question number 2. We are required to show that sine alpha plus 60 degrees is equal to 1 over 10 into 3 plus 4 root 3, given that sine alpha equal to 3 over 5, and alpha is an acute angle. We observe here that alpha plus 60 degrees is a compound angle. This suggests that we may use the compound angle formula for sine, but we know that it will also need the cosine of alpha, so we start by finding the cosine of alpha using the identity cos squared alpha equal to 1 minus sine squared alpha, that is equal to 1 minus 3 over 5 squared, substituting for sine alpha, which is 3 over 5, and simplifying that we obtain cos squared alpha equal to 16 over 25. Then on taking the square root, remembering that alpha is acute, therefore cos alpha is positive, so we get cos alpha is equal to the square root of 16 over 25, which is 4 over 5. Now we can use the compound angle formula. That's sine alpha plus 60 degrees equal to sine alpha cos 60 degrees plus cos alpha sine 60 degrees. And we can now make the substitutions. Sine alpha we are given is 3 over 5. Cos 60 degrees is a special angle. Cos 60 degrees is half. Cos alpha is what we have just calculated, is 4 over 5. Sine 60 degrees is a special angle. Sine 60 degrees is the square root of 3 over 2. And simplifying that, we obtain here 3 over 10, and here 4 times the square root of 3 over 10. Noticing the common denominator 10, we can now factor out 1 over 10, and the required result. In this question, we are given information about two angles, alpha and beta. We are required to calculate the sine and cosine of some compound angles formed by alpha and beta. Now that tells us that we will need both cos alpha and sine alpha. We will also need sine beta and cos beta. So we have to first calculate those that are missing. Let's begin with the angle alpha. We are given two pieces of information about the angle alpha. One is 13 cos alpha equal to 5. The other one is that alpha lies between 0 degrees and 270 degrees. Now we need to use these two pieces of information to locate the quadrant where alpha is. So first, making cos alpha the subject here by dividing by 13 both sides of this equation, we have cos alpha equal to 5 over 13. That tells us that cos alpha is positive. Now we know that cos alpha is positive in the first quadrant and in the fourth quadrant. Now we must go on to decide in which one between the two alpha lies. We are helped by this extra information that alpha must be less than 270 degrees, therefore it cannot be in the fourth quadrant. Thus we conclude that alpha is in the first quadrant. We also compare this ratio with the definition of cos alpha, which is x over r. That tells us that the x coordinate of the point is 5 and r is 13. Now we are ready to sketch a diagram to help us in our calculations. So there is our diagram. The point here is x coordinate 5, the y coordinate is unknown. Then r is 13 and this angle is alpha. Now we need to calculate y. So we'll use Pythagoras theorem. X squared plus y squared equal to r squared. In making the substitutions, we have 5 squared plus y squared equal to 13 squared. Making y squared the subject, we have y squared equal to 169, that's 13 squared, minus 25, which is 5 squared, and that simplifies to 144. Taking the square roots both sides and remembering that in the first quadrant y is positive, so we take the positive root, so y is equal to 12. Then we can write down sine alpha. That's sine alpha equal to y over r, which is 12 over 13. Now we have both cos alpha and sine alpha. The next thing is we must now use these two pieces of information to find sine beta and cos beta. Coming now to the angle beta. 15 tan beta minus 8 equal to 0, sin beta less than 0. We begin by making tan beta the subject. Taking minus 8 across to the right, it will be positive, and then divide by 15. We obtain tan beta equal to 8 over 15, which is equivalent to y over x. Notice that at this stage we cannot conclude that y is 8 and x is 15 until we have taken into consideration the quadrant in which beta lies. We will use the fact that tan beta is positive and sin beta is negative to determine the quadrant in which beta lies. Now we know that tan beta is positive in the first and the third quadrant, whereas sin beta is negative in the third and fourth quadrant. So the first quadrant is out. We conclude that the third quadrant is where beta lies, because that is where tan beta will be positive and sin beta will be negative. Thus beta lies in the third quadrant. Now we are ready to sketch a diagram. That is our angle beta lying in the third quadrant. And we know in the third quadrant both x and y are negative. So x is actually minus 15 and y is minus 8. Now we are ready to calculate the value of r using Pythagoras theorem. That's x squared plus y squared equal to r squared. Then making the substitutions, minus 15 squared plus minus 8 squared equal to r squared. And simplifying, we obtain r squared equal to 289. Taking the square roots both sides, remembering that r is always positive, we obtain r equal to 17. Now we are ready to write down the values of sin beta and cos beta. That sin beta equal to y over r. The y coordinate is minus 8, so that's minus 8 over 17. And cos beta is x over r. The x coordinate is minus 15 and r is 17, so cos beta is minus 15 over 17. We now have all the information we need to answer the questions. 3.1, we were required to calculate sine alpha plus beta. We begin by quoting the compound angle formula. That sine alpha plus beta equal to sine alpha cos beta plus cos alpha sine beta. And now making the substitutions. That's sine alpha 12 over 13 cos beta minus 15 over 17 plus cos alpha 5 over 13 sine beta minus 8 over 17. Then simplifying, we obtain our final answer as minus 220 over 221. (3.2) Cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. Making the substitutions, that's cos alpha is 5 over 13, cos beta minus 15 over 17, plus sine alpha is 12 over 13, sine beta minus 8 over 17. And simplifying, we obtain our final answer as minus 171 over 221. We have now come to the end of this lesson. I hope you enjoyed it. I'm looking forward to seeing you in the next lesson. Do not forget to subscribe. Bye-bye.